Hello students, today we are going to start the remaining topic of last point is pH of the salt. Artha okay, pH of the salt. So we have the value of OH. We already know the concentration values of OH and in a last point. So the OH concentration is C into alpha. We already discussed in last topic. So if this has the value, then we have Kw is equal to H into H plus, concentration of H plus into concentration of OH minus. So using this equation, first of all we calculate the concentration of H plus because we're going to know the pH value. So for that we must have the value of H minus concentration because it is a pH. So that's why we first of all going to know the value of H plus. Here H plus is equal to, using this equation, so the OH minus goes here denominator, so Kw upon OH minus ion concentration, but we have the value of OH is C into H. So we put the value of OH minus is here. So the value of H plus is equal to Kw upon C into alpha, C into H. So this is the second equation. Once we get this equation, we already calculate the degree of hydrolysis. And what is the equation? So H is equal to Kw upon Ka upon the C, and it is converted as a Kw into Ka upon C. So we put this value in above equation number 2. So after it, what happened? H plus is equal to Kw upon C under root Ka into C. This is the after modification, or we directly get this equation Ka into Kw upon C. So once we get this value, then we taking the logarithm. We neglect this one. We just consider this. Okay, Ka into Kw because we solve this one. Here is a Kw. So it is a common. Okay, concentration is common, and then so it is a Kw is common, Kw into Ka, and this comes here, so Kw into K upon C. So we consider this one. Okay. So when we taking the negative logarithm of both sides, so here the minus log of H plus is equal to minus log of under root Ka into Kw upon C. After getting this, we solve it in the next step. It remains as the same, is equal to minus log of. So we just remove the under root into square bracket. So in the square bracket, it considered as a power 1/2. You know the mathematical rules here. After that, minus log of H plus remains here is equal to, here this minus 1/2 power comes out of the bracket. So here it is a minus 1/2 log of Ka into Kw upon C. When we solve it, there is a minus 1/2 log of Kw plus log of Ka minus log of C. Okay, so in next step we shifting the negative charge here in a square bracket. Just transfer the negative charge in a square bracket. So what happened here? pH is equal to 1/2. pH means why? Because this minus log of H plus ion concentration is a pH. So pH is equal to 1/2. So here is the value is positive. So when this sign is negative here, it is a minus log of Kw, the positive sign becomes negative and the negative sign becomes positive. So here minus log of Kw minus log of Ka plus log of C, and you know these two values. Minus log of Kw means pKw, minus log of Ka means pKa. So we just 1/2 pKw plus pKa into log of C. So using this equation we can calculate the pH of the solution when we know the ionic product of the water. When we have the value of pKa means acid strength is there, and if we have the value of concentration, we can calculate the value of pH using this equation. So this is all about the pH of the solution after the hydrolysis. Then we are going to discuss the another points. Okay, let us consider third salt. It is the salt of strong acid and weak base. So when we hydrolyze any salt, first of all we dissociate it, When salt is hydrolyte, it is tendency, their anion or their ions has tendency to react with the some dissociated part of the water. Okay, we're going to discuss one by one. Suppose we consider the hydrolysis of NH4Cl. NH4Cl, which is obtained by reaction between NH3 plus HCl. It gives NH4Cl. So NH3 is the weak base, HCl is the strong acid. So it is the salt of strong acid and weak base. So first of all, NH4Cl is dissociated as NH4 plus and Cl minus. We get the first equation. The dissociated ammonium chloride has tendency to react with the some part of the dissociated water, because water itself as a dissociated as a H plus and OH minus. Okay, so when water is dissociated as a H plus and OH minus, this NH4 plus is react with OH minus of the water. So this NH4 plus of the salt and OH minus of the water are react together and form ammonium hydroxide is the free base. It is a free base is produced. It is the second equation. So overall, when the water is added into salt, salt is dissociated, as well as there some ion react with, and water also some ionized. So ionic form of water and ionic form of salt, they are again react together. So three things are there. The ions are there, NH4 plus and Cl minus is there, as well as their water is dissociated from H plus and OH minus. Then some free base is produced, NH4OH is produced. So overall what happened? On dissociation there is a NH4 plus and Cl minus. We add water in it. So this is the mixture. Okay. So the H plus and OH minus is generated due to H2O slightly dissociate. When H2 is slightly dissociate, it produce OH minus and H plus. This OH minus react with this one and form NH4OH. NH4OH. So this is the reaction is given here. Okay, so when OH minus react with this formation of NH4OH, the Cl minus is remains, and after the OH minus is react here, the H plus is remaining, the H plus is there. So overall, it converts into this NH4OH plus Cl minus H plus. These are not combined, they are separated ions. When we cancelling the common terms, common ions, what remaining? This side NH4 plus H2O and another side NH4OH and H plus. So when according to law, when we find the degree of hydrolysis, KH is equal to product of products upon product of reactants. But here water in a excess is taking as a constant. That means concentration of NH4 into concentration of H plus upon concentration of NH4 plus is the hydrolysis constant of this hydrolysis. It is the equation number 4. Then what happened during this? Slightly some water is dissociate, as well as some free base is produced. It is possible it also dissociate, free base also dissociate. So we are going to consider this dissociation here. When ionization of weak base takes place, NH4OH ionized as a NH4 plus and OH minus. It is equation number 5. And using this equation, using law of equilibrium, we can find out the dissociation constant of base. And when we find out the dissociation constant of base, sorry, here is the Kb. When we find out the dissociation constant of base, it is the Kb is equal to product of products upon upon the reactant. So there is a NH4 plus OH minus upon NH4 OH. We get in the equation number 6. So we calculate the dissociation constant of acid which is produced here, free base is produced, their concentration is, or their dissociation constant we find out. Again, some water is dissociate, So dissociation of water is there, ionization. H plus and OH minus, it considered as an ionic product of the water. So Kw is equal to H plus into OH minus. It is the equation number 7. So when we divide the equation number 7 by equation number 6, we get Kw upon Kb is equal to H plus and OH minus upon NH4OH upon NH4OH, NH4 plus OH minus. These twos are common terms. We cancelling it. So what remain on the numerator? There is a NH4 plus and H plus. So H plus and NH4 plus on the numerator, and at denominator there is only NH4 plus NH4OH. So this is obtained during this. It is equal to KH because same value is here. KH NH4OH H plus NH4 plus. Okay, so both are, we are getting the same values of both. H plus NH4 plus here NH4OH. So it is equal to KH, both having the same value. Just a minute. Okay, so here KH is equal to Kw upon Kb. So this is the hydrolysis constant of the strong acid and weak base. So KH is equal to Kw upon Kb. Using this we can calculate the value of H also, degree of hydrolysis. So we are going to calculate degree of hydrolysis. Okay, so how to calculate degree of hydrolysis of given salt? So we write the equation for salt hydrolysis, NH4Cl plus H2O. It reacts. So when salt is hydrolyzed, we getting the acid and base. So here HCl is the acid, NH4OH is the base is produced. Okay, so what is the degree of hydrolysis? Suppose we consider at initial stage there is a concentration of NH4Cl is considered as a C, then that time the concentration of acid and base is 0. But at equilibrium, if some degree of hydrolysis takes place, that means C into H is the concentration of NH4H. Means what is the concentration and what is the degree of hydrolysis in this product is the present at the equilibrium point. So C into H is the concentrations are considered of acid and bases. So that time, what is the concentration of undissociated, unhydrolyzed NH4Cl? So it is a 1 minus H. Because of H is the degree of hydrolysis. Then, if we consider 1 mole, some molecules are hydrolyzed. So 1 minus H is the remaining concentration. 1 minus H is the remaining concentration. So according to law, the equation is NH4OH and concentration of HCl upon, this is the excess, that's why we neglect it. So here NH4Cl, this is obtained by the laws. So we put the values of concentration here. So what is the concentration? C into H into C into H upon, here is a C, 1 minus H. That means here C into C is common, there is a H square upon, here is a 1 minus H. So KH is equal to 1 minus H. If we consider the hydrolysis is very negligible, means it is almost equal to 1. So 1 minus 1 it is considered. If here only 0.01% is hydrolyzed, so it is the value unhydrolyzed, it is very close. So 1 minus H is very close. So if H is smaller, if H is larger, that time there is a importance. So that time if H is also considered as a 1 if there is a smaller hydrolysis happen. So 1 minus 1 it is 0, that means KH is equal to C into H square. C into H square. So H square is equal to KH upon C. H square is equal to C comes here at a denominator, so KH upon C. So H is equal to, it is a square, so this side is going under convert into under root. So here under root KH upon C. But in last we already find out the value of KH. So there KH is equal to KW upon KA. KH is equal to, we already recently calculate, KH is equal to KW upon KA. So we put this value here. So under root KW upon KA upon C. So both the denominator comes here. So KW is equal to KA into C. So H is equal to under root KW upon KA into C, and this equation used to find out the degree of hydrolysis of acid and bases or their salt. So this way we can find out the degree of hydrolysis. So last point we are going to discuss it is the pH of the solution. Once there is a hydrolysis is successful, what is the pH of given solution? We are going to find it. Okay, so find out the pH of the salt. We already find number of things. We have the value of H. We have the H plus ion concentration, it considered as a C into H. Same as in previous, there is a OH minus IS concentration is considered as a C into H. So here we put the value of H we recently calculated as H is equal to KW upon KB into C. So if we put the value of it here, it under root KW upon KB into C. So we solve it, it is considered as a common constant. So here under root, when it comes into under root, that time the C comes at numerator and multiply to the KW. So KW into C upon KB is, we are getting the value of H plus. So we are taking the logarithm, negative logarithm of both sides. So minus log of H plus is equal to minus log of under root KW into C upon KB. In next step, there is a minus log of, we just solve the, or we just remove the under root into square bracket. So it comes as a KW into C upon KB with power 1/2. Taking this outside the square bracket or to the at here, so minus log of H plus is equal to minus 1/2 log of KW into C upon KB. When we solve this bracket, so here it is a minus log of KW plus minus log of C minus log of KB. We are getting this. And when we shift the negative sign into square bracket, the positive value converts into negative, so it is minus log of KW. The positive converts into negative, it is a minus log of C, and the negative converts into positive, it is a minus plus log of KB. We have already know there is a minus log of KW is equal to PKW minus PKB and plus log of C, because of we already have this value. So this comes here. So pH is equal to plus 1/2 under root in square bracket PKW minus PKB plus log of C. Using this equation we can solve, we can find, we can calculate the pH of the salt during this hydrolysis. So we stop here today.